Hi everybody, this is John from pythonbeginners.com, welcoming you to lesson 4 of my Python Essentials training course. In this lesson, we're going to talk about the if statement. So if I go to my website, pythonbeginners.com, all of the material I'm taking from the lesson is coming from this website. Specifically, this time around, lesson 4. So an if statement, as you can see on my site here, it's something that allows your code to make its own choices by following the rules you set up to guide it to the right choice. So all programming languages have if statements, and all programming languages need to give you the ability to say, hey program, I'm going to give you 5 choices and I want you to pick the best choice based on the rules I'm going to set out for you. So Python's no exception to the different languages. So in Python, to do an if statement would look something like this. So I'm going to start by taking this really simple two-way if statement. So I'm just going to copy the code right off my website here. I'm going to paste it into my idle programming window, and I'm just going to quickly save it. And once I've got it saved, I'm just going to quickly run it for you. And it's a very straightforward program. I'm going to enter my mark on a test, and the rule I'm giving my program is if the mark is 50 or more, like 55, then I want the program to say you passed. But I can run it again, and I can put in a mark of, say, 35, which means I failed. So take a look at the code here. Very straightforward. We're asking for a mark as an input, converting it to an int. And here's how we say it. If mark greater than equal to 50. And then we put a colon here to indicate the end of from that part of the if statement. And then I've got the instructions what to do. If I'm over 50, else, colon, print, sorry you failed. Notice these two print statements are indented. That's a big thing in Python. When you indent code, it means you're associating it with one particular choice. So if there are more things to do on either of these choices, I would just keep indenting, and then that's how Python would know that that's what it has to do for that particular choice. Now this particular example is pretty straightforward because we're only looking at one choice or another. So in other words, option A or option B. But quite often you want to write code that has more than 2 choices. So if I scroll down further on my website here, here's an example here where we are not only saying pass fail, but we're converting a mark into a letter grade. So if you take a look at the rules of this, I'm asking again for my mark, but now I've got 1, 2, 3, 4, 5 different possible choices. And the way we say that in Python, the first choice is always if, and then we put the rule that needs to be followed in order to do this choice. Okay, so these 2 lines indented are associated with if mark is greater than 80. Now if there are additional choices, we break into another thing called an elif. So elif is every choice after the first one, but not the last one. So our last choice is always going to be else, meaning anything else. If I haven't picked anything else yet, then do this last choice. But in between, it's almost like a sandwich. I have a series of these elifs. So elifs are very much like ifs, except they're just not the first choice. You've got to put a rule beside each elif that has to be followed in order to get that code to run for that choice. So over 80, I'm going to do these 2 lines of code. elif mark greater than equal to 70, I'm going to do this one line. 60, I'm going to do this line. 50, I'm going to do these 2 lines. Anything else, so if I haven't yet found something to do, then my final default choice is to say print sorry you failed. Now with this program, I've also put some code after the if statement. So this last line here is mandatory code, meaning that it's not part of any if statement, it's not part of any choice. So it's going to run automatically regardless of which choice was made up here in the options. Okay, so the best way to see this in action is to just copy it, and I'm just going to paste it into the same window that I had before. So I'm just going to overwrite this one, and I'll paste this, and I'll just save it again, and we'll run it into the idle shell. So this time around, there's 5 different possible things that can happen. If I put in a mark of over 80, I get an A, and it also says well done. So because I typed in a mark of 85, it chose to run these 2 lines of code. All right, but I can test that with other marks as well. So I won't run the video for every possible option, but let me try 65. 65 runs 1 line of code, you got to see, but notice regardless of which choice was made, it says thank you for using the program afterwards. Now this program is pretty smart, but it does have some flaws. So for example, if I type in a mark of 2500, well, that's going to be an A because it's over 80. And we've said to our program, hey program, anything over 80 gets an A. Also, if I run this and I say I got a mark of negative 99, then I've got a failure mark. But in a real program, we'd probably want to do a better job and protect our code from these out of the ordinary inputs like 2500, negative 99. Maybe we want to make it so that our program only responds to marks between 0 and 100. And if it's not in that range, we give them some kind of an error message. So my third version of this program just gets that much smarter. So take a look at this example down here. So with this one here, I'm using the word and to supply two rules for each possible choice. So now I'm saying to my program, the mark has to be over 80 and the mark also has to be less than equal to 100. So we can use this and to join two rules together, and with and both have to be true in order to get the A. All right, so I'm doing that all the way down for B, C, and D. I'm giving a range now between 60 and less than 70. So take a look at this one, for example. Greater than, equal to. That means 60 or above. On the upper side, I'm saying less than 70 without the equals, which means 70 will not be included in the C. 70 gets included as starting of the B range. All right. So all the way down to 0 to 50 is failed, and then anything else will print invalid mark must be from 0 to 100. So anything else could be literally anything else. This could be any mark that's over 100 or any mark that's under 0. But I don't need to say that. I just say anything else, and the program knows that if it's not one of these possible choices, it's going to come down here and do this instead. But again, regardless of which choice it makes, it's still going to print this mandatory, or run this mandatory code at the end. So it's going to print this statement here. So I will just quickly copy this and I'll paste it into my program window, and I'll run it one more time. I've got to save it. This time around, I'm just going to focus on the errors that come up once I fix this minor error here. All right, let me try that again. Okay, so if I put in a mark of, say, 2500, this time my program's smart enough to know that anything else is going to be an invalid mark. But that same choice will be made if I type in a negative number. So if I run it one more time, and I type in negative 76 and enter, and it chooses that same else statement, or that else choice again. All right. So using and is a way to make our program smarter. It provides us with more than one rule that we can use when making different choices. Next, I want to talk about nested if statements. So sometimes you'll be writing code where you're providing choices with your program, but then when you make one choice, a whole other set of choices comes into play. So think of a video game where you can choose between, say, choice A, B, and C, or door 1, 2, and 3. And then you choose door number 2, and then a dragon comes at you, and then you have to choose between which weapon you're going to use, or if you're going to run away from the dragon and not fight him at all. So that would be considered a choice within a choice. So to do something like that, we need an if statement inside of another if. And this is quite common in programming, regardless of what language that you're using. So this is called a nested if statement. I've got a very simple example here I want to show you based on going to a movie. So we're going to say the cost of a movie is $10, which is probably a little low these days. And when we get to the movies, we're going to ask the person if they want popcorn or not. Now, if they say yes to popcorn, and notice I'm saying or in this case, because they could have answered a small y or a big Y. So just like and, we can use or to combine rules together, but or means one or the other needs to be true in order to do this choice. Now, if I answer y or capital Y, we're going to charge $5 for popcorn, but then another choice presents itself inside of this choice, and that is, would you like butter on your popcorn? So once again, we're going to ask yes for butter, and if we say yes, we're going to add another $1 to the price of our total movie ticket bill and say butter's been added. Else we're going to say butter has not been added. And this else out here is part of the outer if statement. So up here, if I don't answer y to popcorn, it's going to come right down here and say popcorn has not been added to your order, and that way no other costs have been added beyond the $10 of the movie. Okay, so what we've got here is an if statement that's inside, it lives inside the yes side of do you want popcorn. But obviously we're not going to ask somebody if they want butter if they don't order popcorn to begin with. That wouldn't make any sense. So that's why this choice for butter is nested inside the outer choice of yes or no, do you want popcorn? So I'm going to take this and copy it into my idle window. So I'll just highlight that and copy, and I will paste it into here. And this saves the time for you watching me type this code out, because the code's already been typed out and I've explained it all to you. And if you go to my website with all this code, of course, you can copy and paste it and try it on your own and change it around a bit if you want, just to learn a little bit more about how it works. But let me just run this once and I'll demonstrate how this program works for you. Okay, so down here at the bottom, it's saying, welcome to Cineplex, would you like popcorn? So the first time around, I'm going to type any other letter, say T, to decline. And that's going to take me right out to the end of the program. And it's going to say popcorn has not been added, your total is $10. This time I'm going to order popcorn, and that's going to present me with another choice. So now it's saying popcorn's been added, and now I've got a choice of, do you want butter? So I'm going to say no to butter this time, so that you can see my total bill is $15. I'll run it a third time, and this time I'm going to say yes to everything. I want popcorn, I want butter, so that should bring me to a total of $16 for everything. So you can see by running this program 3 times, I finally was able to get every line of code to run. But it's impossible for all this code to run every time you run the program. It's going to pick something to run, and depending on what's going on in the program, it'll choose one thing or another. And again, it's all based on the rules that you apply when you write your if statements. Now with this program too, it's another good example of how indentation works. So notice that this bunch of code here is indented under if answer equals Y or answer equals capital Y. So actually all of this code here, so this entire segment of code is associated with saying yes to popcorn. But within that, we have code that's associated to saying yes to butter. Okay, and this is tabbed in twice because this is actually part of this inner if statement, as is this else part here. So this is indented as well because it's associated with just this one little else. And then we have another indentation here for the outer else. All right, so indentation is really important. It helps Python detect what lines of code are associated with what choice in an if statement. So always make sure that you use your tab key to tab code in that's associated with one particular choice or another. So we'll finish this lesson off by talking a little bit more about comparing for equality. In all the examples I've shown you, we use different ways to ask if two things are comparable to each other. So for example, I can say if something is less than by using this less than symbol. A lot of people get less than and greater than mixed up, but this is the less than symbol. Less than or equal to would be these two together. Equal to is two equal signs. So you don't use one, you use two to compare things to say if they're equal to each other. If I use one equal sign, I'm saying let x equal y. With two, I'm saying does x equal y? I'm asking a question. Not equal to, although we didn't show it in an example here, this is how you'd say if x is not equal to y. Then there's greater than equal to and simply just greater than. So these are the different ways that you can compare things in an if statement. So that's it for this lesson. Hopefully you learned something about how to write if statements in Python, and we'll see you in the next lesson where we're going to talk about loops. This is John from pythonbeginners.com. Thanks for watching.